Welcome and thank you for joining us today. My name is Kamla Delahaye and I'm a labeling specialist here at Polyfuse and Molden Graphic Systems. I will be the moderator for today's webinar. If you have any questions or comments during the presentation, please use the comment section on LinkedIn. We will answer questions live towards the end of the presentation. Today's webinar will be presented by Jason Brownell. Jason is our Technical Success Director and has over 30 years experience with polymer fusion labeling. He will be joined by the Vice President of Traceit LLC, Rob LeBrant. Mr. LeBrant is an expert in all things asset management. Thank you for joining us today, and let's get started.
Well, Kamla, thank you very much for the introduction. Looking forward to it, had a lot of great response. And before we jump into Traceit LLC, kind of want to talk a little bit about polymer fusion labeling, what it is, what the challenges are. We're specifically talking about polyethylene, polypropylene, and the polyolefin family of plastics, which certainly have a challenge. First and foremost, very low surface energy. Nothing wants to stick to this material well long term, and we don't stick to it either. You'll learn more about that here in a moment. But it has very low surface energy, which nothing wants to stick well to it. Also, it's constantly expanding and contracting as it gets hot and cold. So that's another big challenge. You also have a lot of outgassing involved with olefinic materials, which make it a challenge for bubbling and blistering and things like that. A lot of people come to us for, different types of properties, brand recognition being one of them, instructional things, warnings, such. But today we're going to be focusing on track and traceability. Now, this is going to include all sorts of things. And again, thank you for joining us today. For example, this could be talking about barcoding, different types of symbologies, and Mr. Rob LeBrant will go into some more detail on that. But this is also going to talk about something that we are bringing to market, and it is our RFusion ID, understanding that there's a real need in the plastics industry for a fusible type of RFID. Whether this is a rotationally molded product, blow molded, thermoformed, injection molded, having a solution that actually fuses into the plastic rather than trying to adhere to it. So again, we are located here in the United States in Central Arizona. There's some of our contact information there. But without further ado, I'd like to bring to the stage our special guest, and that is Mr. Rob LeBrant from Traceit LLC. Rob, can you tell us a little bit about your company and kind of the history and what you do?
Yeah, good morning, everyone. Appreciate your time today. Traceit LLC is a small consultancy that we started after more than 30 years with the U.S. Department of Defense, leveraging the automatic identification data capture expertise that the last 10 years of my career, we're working internationally, both with NATO and with NATO nations, leading the U.S. DoD and item unique identification from 2003 to my retirement in 2012. I've also like to focus a little bit on our interaction with standards community. We've been active with ISO, ANSI, AIAG, most recently Underwriters Laboratory, and for quite a while AIM, which is the Automatic Identification Data Capture standards group. Our involvement there is really to look at what are the technology opportunities and what can we bring to the, in my terms, marketplace, meaning the user community, technologies that better perform than the existing technologies. We'll talk a little bit about what we've done with Polyfuse to put polymer fusion on the map in my experience, the lack of good marking in the plastic space is a real problem. Our company also does support in terms of business process reengineering and mapping. We've done such work as warehouse management system installation support to the U.S. Department of Agriculture. We took 14 separate instances of NASA's Maximo implementation as they went to Mass 8, mapped that, and identified an implementation plan to get them there, including AIT, but also including general business processes. So a little bit of everything, and it's been interesting.
That's awesome. Yeah, the unique technology that we bring is a label that, rather than being adhered and being adhesive based, it's actually made from polymers, and through the use of heat, we are melting our material into the olefin plastic. And so I just wanted to kind of clarify that for everybody. You talk about these markings. So kind of what kind of product offering do you bring exactly to, track and traceability? Like if a person was to work with you right now, what would you be bringing to them?
Right. So the first thing that we do is look at why they're marking items. What's the purpose? Oftentimes it's simply brand recognition. It might be logos. It might be a QR code to a website for more information. We would help them with the automatic data capture part of it, creating the barcoding, although from a URL perspective, that's pretty straightforward. But we'd also look at what they're doing in brand identification or product identification. What are the part numbers, model numbers, serial numbers? How do you represent that? How do you package the item in many cases? What's the data being used for? Is it a consumer facing like a QR code typically is from a marketing perspective? Or is it for internal use? Oftentimes you'll see a product that you're using in your everyday life with multiple barcodes on it. And you'll probably ask yourself why. We ask that why up front. Why multiple barcodes when one 2D barcode could carry all of the data in one unambiguous data capture? There may be a legitimate reason. Maybe it's an infrastructure issue. Maybe you only have red line laser scanners. You don't have imagers. That may make a difference. But we look at what it's for. Is it for customer support? Is it for, oftentimes you see these barcodes and they're really for internal traceability in the warehouse or in the manufacturing facility. It's part of the build process. I know a lot of the fantastic examples that Kamla and Polyfuse have posted have to do with safety, health, and operating instructions. Are they clear throughout life? Well, if you can't read the barcode or you can't read the label, they're obviously not clear throughout the life of the asset. And then finally, one of the areas that I particularly am passionate about is authentication, provenance, and anti-counterfeiting. One of the things that we realize in our everyday life is that lots and lots of people get products counterfeited. And what we've tried to focus on is what can we do to a product through its labeling, whether it's an additive label, whether it's polymer fusion, what can we do to make covert inroads into assuring that product is authentic? So that's an area such as the detect crystals that Polymer Fusion uses, watermarks, digital watermarking. There are a lot of different techniques that can be used, and we like to focus on that. And then the last thing is product lifecycle management. What are you doing with the product, and how are you using it to do property management, to do electronic records or technical publications, access to those through the barcoding and labeling.
For sure. Well, one quick slide I want to pull up here, Rob. You kind of touched on it just a moment ago. You were talking about 2D barcodes, and I see a real shift, especially from a security standpoint, with 2D data matrix. Can you share a little bit on that and kind of what that can do for a person rather than having multiple, code 128s, for example.
Yeah, no, exactly. So it does a couple of different things. One is the payload that you can carry on a 2D barcode is significant, up to a couple of thousand characters in a quarter by a quarter inch square. If you're looking at, so for example, the data matrix code shown there is the most common in product traceability, certainly the most common in the defense space, both nationally and internationally. Under item unique identification, the 2D data matrix, as opposed to any of the others, including the GS1 data matrix, specifically the ECC200 data matrix is the standard. The other huge advantage is that typically we would require encoded symbol structure. What we call hidden characters would be encoded within the barcode. What they do is they give you what I describe as the punctuation in the sentence. So you can have a string of words together, but without commas and periods and question marks and exclamation points, it really has potentially little meaning. What the syntax inside of the barcode does is give you separation. So you could have 20 pieces of data inside a data matrix with the data qualifiers to separate the data. You can put part number, serial number, manufacturer, expiration date, all in one barcode separated so that when you decode it, you get unambiguous pieces of data with the data tags on them. That gives you the ability to capture not only everything in one shot and not risk scanning the wrong, what we call a naked 1D linear barcode that typically would not contain such character sets to assure accuracy. It allows you to do that in one scan and pull 5, 10 pieces of data into the system clearly tagged as to what that data is. And they're also much more reliable. We've all been to the grocery store or the big box store and tried to scan a 1D linear barcode and failed. These barcodes, particularly the ECC200 data matrix, are very recoverable in terms of damage. The other thing this slide shows is that barcoding is one of many track and trace technologies. We're just submitted a draft study that looks at automation technologies for a new facility, everything from vision and AI to passive RFID, GPS, and sensor tags, and barcodes. But certainly barcodes and RFID are the centerpiece in most implementations. But tracking vehicles on a facility, for example, is more akin to something you'd use with a GPS tag.
Sure. Excellent. Can you talk a little bit about your experience on having, say, a good label versus a bad label? Like, what happens in the industry when there's, say, delamination, for example, or
right.
tag separation.
Yeah. So what we have found is that the first error that's made is the assumption that somebody who can design a jet engine can also design labels and data plates. It's and other types of marking. It's simply not what they're trained to do, but yet we often ask people to do that. So what we end up getting is sub-optimized solutions that maybe meet their specific requirements in the near term for tracking it through a facility and to a user, but oftentimes they fail in the long run. One of the biggest examples of that, and is why we partnered with Polyfuse, is that plastics, as you said earlier, low surface energy, very difficult to adhere to. Most of the time adhesives are used. Adhesives often fail fairly rapidly. The other big example of that is, well, there's a couple. One is chemicals that might be introduced to a product, either through cleaning or through storage. Those chemicals can dissolve adhesives. They can dissolve the substrate materials. They can dissolve the label material. And the last area that's very common is exposure to UV lighting. UV lighting will strip the barcode label data very, very quickly. So what we do is we look at what your holistic application is, not only what you're doing with it, but what you're doing in the long run, and come up with a solution that fits that. Polymer fusion is the only system that I've found that could reliably mark something like a storage and transport case used by the military for weapon systems, or what you would call a Pelican case in the common vernacular. I know that's just a brand, but in any case, those kinds of cases, as well as reusable containers used in bread distribution, used in warehouse parts bins and sorting, those kinds of labels will come off if they're not properly engineered, and polymer fusion avoids that problem.
Sure, thank you, Rob. You know, it's interesting you bring up the adhesive portion of it, and I think about like in food or the medical industry, when you have adhesive labels that fail and maybe adhesive that residue that is left behind, it would seem logical that that would be a point of harboring bacteria as well.
Yeah, 100%, and the claving processes and other sterilization processes are made much easier by something that doesn't have an adhesive back.
Sure.
So direct part marking of a variety of is used in the medical space, whether it's laser marking of pieces of medical devices or scalpels or those kinds of things that are used to track those in the surgical room. They're primarily done that way to avoid the possibility of introducing harmful bacteria and other viruses and such.
Sure. Great. Thank you. And can you talk a little bit? Yeah, I know you've been involved in I believe you were involved in a white paper. Also, you mentioned earlier some standards. Can you talk a little bit about those documentations that you've been involved in?
Yeah, sure. So one of the major standards was MIL Standard 130 in the US DoD. That's coming up for review this year, and we'll be involved in that. But in the interim, we looked at additional standards, particularly on the military side, that existed, and looked at while we were modifying those standards, what could we add to them? And we did add a number of technologies, both polymer fusion, as well as the introduction of submicron particles for authentication, as direct part marking methods that could be beneficial. There wasn't, as I said before, a good solution for plastics marking, so we added polymer fusion to, for example, the Canadian Forces standard on item marking. There's a long designator, so I won't get into that, but we can provide that separately, as well as storage and shipment marking, which deals with reusable packaging and containers. I know Polyfuse and I have been involved with Underwriters Laboratory looking at 969, which is the standard for marking and labeling systems, to make sure that it had a level playing field and that it really did test products on plastic substrates. So there was a lot involved with that. The white paper you mentioned was really interesting. It's from the Reusable Packaging Association. Mm-hmm. It came out this year. I'm sure Jason could provide the link to that.
Absolutely.
It's called a Smarter Technology-Driven Supply Chain with Reusable Packaging Systems. And it has everything in it from barcoding and RFID to how to use the data. There's also a cost estimation calculator, which is used for calculating the return on investment for using reusable packaging. But for our purposes, the thing I would point to you in the white paper is physical marking, tracking using both barcoding and RFID and other technologies. It was a really interesting white paper to put out, and it's been well received.
That is awesome. Yeah, I had the pleasure of reading that, and well done to everybody that was involved in that. So was great. As we kind of wrap things up here, and we're going to open things up for questions and answers, can you tell us kind of what's on the horizon for Traceit LLC? Do you have any things that you're working on right now?
Yeah, sure. We have a couple of interesting new projects, both relatively new. One is, I think I briefly mentioned, is a European military base that we're working at that has identified 10 use cases and 11 technologies, or we've selected 11 technologies across the 10 use cases, evaluated their usefulness, and evaluated their capabilities. And that's everything from barcodes and RFID to vision systems with AI to spot vehicles and other pieces of larger equipment, typically, on the facility for quick location. The second one I'd like to mention is we were selected as part of a team to look at track and trace of body armor. Specifically in this case by the European Defense Agency, which is seeking to create a digital product passport concept. So you'd be able to scan the unique identifier. In this case, we would follow the same standard, probably. It's to be determined yet, but it looks like we would follow STANAG 2290, which is the NATO STANAG, which is item unique identification, which we started in 2003, believe it or not, in the US, and I had the privilege of leading in NATO. And that identifier, then globally unique, reaches to a secure database. Through that secure database, you can get everything you need to know about that item. One of the biggest challenges is inserts inside of vests holders. And the question is, what is the expiration on that item? Has that item encountered damage? Are you going to replace it? Do you nest a child-parent relationship through life or not? And how do you handle that? So we're working through that process right now, as well as the data model to go with it. So it's pretty interesting. And of course, I think the work that's coming out here relative to the integration of the RFID tag into the Polymer Fusion label is really a revolution, because if you think about it, typically plastic items are marked with a barcode label sometimes, but more often with some sort of branding or stamped. The ability to introduce an RFID tag as part of the marking process that can then be utilized throughout the life of the asset is significant, because what typically would happen in today's world is an added passive RFID tag would be placed on the asset, again, adhesive, would not last the life of the intended use of the item. So incorporating that into the base product marking is a huge advantage.
Awesome. Well, thank you for that. And I'm going to go ahead and bring Kamala back. I know there's been some questions. We had some questions ahead of time. So I'm going to bring her back to the stage. And Miss Kamala, are you there with any questions?
Yes, thank you, Jason. I do have had a couple of questions come through. The first is, how are specific details programmed into the RFID label?
Yeah, that's done through an encoding process where the information is uploaded to that particular tag or particular chip. Rob, would you like to go into a little more detail on that?
Yeah, so there's a couple of things. One of the first questions I ask people is, how much data do you actually want or need on the tag? And can you track that data? Or do you need to change the data through life? So RFID tags come with an RFID tag ID included within the tag itself. Oftentimes that becomes a pointer which you can use without encoding.
Sure, a TID number.
Exactly. But in other cases, you may want to program in or encode in a particular identifier. In that case, as you said, it's simply an encoder. You add that data. But I would encourage people to really think about what data is necessary and what you can reach back to data systems to pull. The whole point about ISO 15459, which is the ISO standard for unique identification, is to create a unique pointer. a unique instance of an item that can be leveraged to pull information from existing data sources, as opposed to trying to keep the data on a part current through its RFID tag or even its barcoding. Current part numbers are really challenging because, particularly in the military, because we do a lot of dash numbers, meaning we do something to it, it becomes a -1. We do something else to it, it becomes a -2. Well, in each case, if I'm going to keep the current information on the part, whether it's a barcode label or whether it's a direct part mark, I've now got to update that information, which means obliterating the existing mark and replacing that mark. And in the case of RFID, obviously it's staying coded, but it's an opportunity to miss critical data conversion in the process that might come back to bite you later on.
Yeah, absolutely. So you're saying some people will just simply use that unique TID number, and then as far as the data that they want, rather than putting it on the tag, that is captured in software.
Right.
Is that accurate?
Yep, that's right. But typically that isn't the way people do it. They usually will encode a unique identifier of some sort in the user memory portion of the tag. I believe you'll find that the access is a little quicker that way and more recognizable. And you have great confidence because you've created the uniqueness yourself.
Sure, that makes sense. And I know, from our perspective, and that was one of the questions, they can come from us encoded. If you provide the data that you want to have, we seem to find that a lot of the customers want to receive in a fully encoded tag, but then some people want to have control of that on their end. So, no.
Yeah, and that also comes down typically to your unique identification approach. So if you're using a license plate tag approach, which essentially, when you go to the Department of Motor Vehicles and you get a license plate for your vehicle, you don't control what the data is on the license plate. It is what it is, and it gets associated with your vehicle.
Sure.
That's essentially what the license plate mentality is. So you could get a ream of RFID tags encoded from X to Y, X to triple X,
sure.
And whatever the identifier is, when it's attached to an item, it gets associated with the item. That's the license plate approach. The other is no, I want to know this is XYZ732, and I'm going to encode that in the RFID tag, which means I need to have procedures and processes in place to make sure that tag gets on that asset. So it's a little more complicated. There's value to both, and it just depends on what your business processes are and how much value you can derive from that.
Great, thank you for that. Ms. Kamala, any other questions?
I do have a couple other that came through. Maybe these two could be answered together. How long will a Fusion RFID label last? And will it hold up to like an autoclave or pressure washing process?
Yeah, absolutely. We have some great test data going back to a Volvo standard as far as pressure washing is concerned, and I can get those specifications put out as well. So yes, now the particular chip that we are utilizing is an Impinj Monza 6P, which if you go and look at that particular chip, life cycle on that chip is about 100,000 cycles, or 100,000 scans. So it's not really so much about the RFusion ID tag as much as it is about the chip. And so anyway, that's is that kind of a standard route in the industry?
Yeah, no, it's definitely one of the most common chips used out there. And it will come down to the chip itself. There's nothing more dangerous than a maintainer with a pressure washer that wants to go crazy, or is bored. Military are good at that as well. It's just human nature that see if I can peel that label off. Well, with the polymer fusion, they're going to have a really hard time doing that to the label itself. The chip, on the other hand, like any other, it is what it is, and we'll have to see how industrious they can be to take them off.
Yeah, for sure. And what Rob is alluding to there, again, there's nothing really to delaminate because the label material, the tag itself, is polymer based and fuses in through the use of heat into the plastic versus say some sort of a vinyl decal that would have a tendency to delaminate from that surface because of adhesives and the low surface energy of the material. So, no, thank you for that, Rob. Kamala, any other questions?
The last one I had is, how are the labels actually applied to the part, or what kind of equipment is required to put the RFID labels on?
Yeah, no, thank you. I can certainly address that, and it kind of depends on the manufacturing process of the plastic item itself. In the case of rotational molding, we actually have a product offering that will go into the mold. It adheres to the mold wall. You then pour in your plastic resin, where it then goes into an oven to go through the curing process or cooking. It goes into a curing or a cooling station. And then when the part comes out, that RFID is now part of the plastic, or the R Fusion ID is part of the plastic. Now, we also have a secondary or a post process that utilizes a piece of equipment, such as like a hot stamp or a heat transfer machine, where we're actually taking the finished product and then applying the RF Fusion ID through the use of heat and actually stamping that into the surface. And then of course you can come on top of that and stamp it with a barcode or part color or what have you, depending on whether you want to make this covert or not. So yeah, there's two methods. And for in mold, it's strictly for rotational molding, but then for all the processes, it can be done as a post molded process through the use of a stamping equipment.
Thank you so much, Jason. That's the end of the questions that I've had thus far.
Great. I did have a question somebody that had asked in the past was working with compound curves. And that can certainly be a challenge. And so single curves, not so much an issue, but when you start to get into compound curves where it's going in two different directions, that can be a challenge. So, to everybody that's listening, just as you're looking at areas on a particular part where you're thinking about putting this information, consider that it be a flat area or at least only have a single curve and not compound curve. So, and then just had another question pop in here. Is it possible to read the RFID with a phone? Rob, you want to take that one?
Yeah, you can use the near field feature on your phone for certain types of RFID, but you'd be much better off not just using your phone.
Right, utilizing a scanner. I know that's very popular to read QR codes, and it takes you places, but yeah, it's really designed for scanners. And in fact, I'm looking forward to this series because, and thank you for being our first guest and bringing Trace It to us. But we're going to be joined next week by Helen Barker, that is from HID Global, and she will offer some great insight. And then we do have another one coming up on the 21st, so look forward to that. Kamala, any last minute questions that have come in, or?
No, sir. Jason, that's all I have so far.
Excellent. Well, Rob, thank you so much for joining us today and being such a wealth of knowledge, and look forward to working with you on many projects to come.
Okay. Well, thanks for having me, and I hope everyone has a great day.
Excellent. Thank you, Rob.
Rob, Jason, just really quickly, I did get another question. It says, will it withstand the heat or steam from an autoclave?
I don't have specific test data related to autoclave. We do have the Volvo standard for pressure washing, which is very high heat with the water, but I do not have specific information on autoclave.
Kamala, is the question, well, I guess I don't know if the user could clarify, is the question related to polymer fusion or polymer fusion with RFID, or?
It just does say, will it withstand the heat steam of an autoclave, and the LinkedIn user I'm not able to identify. Okay. I do know, Jason, maybe you could speak of it, how our fusion labels have stood up to the autoclave process. We have data for that, for the labels themselves. We just don't have it for RFID, correct?
That's correct. I don't have the data specific to, chip information as far as autoclave is concerned. I certainly know how the polymer fusion material withstands autoclave, but I would rather dig into and get some more information specific as to the chip and autoclave.
Yeah, so the polymer fusion label itself, being that it's becomes a part of the object, is going to be very survivable in that space. If it's not, then you're tearing up the substrate to begin with, which isn't going to be very helpful either.
Right.
So I think the answer to that certainly no problem at all relative to the base labeling process.
Correct.
Thank you. And we did have another user say that it should be no problem with autoclave. So thank you for that.
Yeah, absolutely. Thank you. All right, great. If there aren't any other questions, this will be available to watch as well. If there's somebody you'd like to share this with, it will be available to watch. And again, this is part of a series. Today being the 7th, we have one on the 14th and the 21st. So again, next week will be Helen Barker from HID. And appreciate everybody's time today and all the great questions. Take care and have a great day.
Thanks, everyone.
Thank you so much. Thank you.